So, my name is Cherry Lam, and I know what you want to eat. Just a little bit about myself. I have a weird background in food and protein chemistry. I used to work with a lot of plant-based proteins and investigating their functionalities. We're trying to replace animal-based proteins with plant-based proteins. But my current journey is really a software dev at OpenTable search team. I do mostly backend work, Node, obviously. And I build the API that helps recommend the best restaurants desirable to one's heart. A little bit about myself, hobbies-wise. I'm kind of like a human Alexa. I like talking about restaurants, food all day long. You can ask me about what you get in Mission or anywhere in San Francisco or somewhere else in the country. I also like to make food. I brew beer. I brew wine. I also like to drink scotch. So how do I know what you want to eat? And what happens when you search for sushi in San Francisco on OpenTable? Today I'll talk about what we call a query understanding API that's built with Node and ElasticSearch. So what happens when you search on OpenTable? And I'm sure you guys have used any search engine that is readily available to you, like Google, and hopefully OpenTable, and maybe Yelp. And what really happens there when you type in, say, sushi in San Francisco? What actually happens? And we'll find out. So what is the need for query understanding? Why not just type in whatever you want to and execute a search engine and use some machine learning stuff to retrieve all the rank results? Why do we need that? So oftentimes full text search actually give you pretty bad results. And what I mean by full text search, I mean you could search for, say, sushi in San Francisco lunch. It might give you weird results. You might end up at a restaurant called San Francisco with sushi on their lunch menu, which is, I don't think that's what you want. The other need for building a query understanding API is really to build your search experience as a communication on top of just giving you really relevant results. And there's this gentleman called Daniel Toklang, and he's written many blog posts that are amazing about query understanding API and why we should build the search experience as a communication, and feel free to Google him and read about that. But the need of query understanding really comes down to understanding users' intent. So let's say you search for Mission Chinese, right? Are you looking for Chinese food in the Mission district? Or are you looking for the very famous restaurant called Mission Chinese? And has anybody been there? All right. They make really good tantan noodles, I have to say that. Yeah. And also, when you search for, say, downtown Chicago, it's pretty obvious that you are looking for restaurants in downtown Chicago, right? And you can also search for, say, new in LA, meaning that you're probably looking for restaurants that are new in Los Angeles. Yes?
Francisco is misspelled in the search bar.
Thank you. That's a good point, because I'll talk about it in a bit. So what is query understanding? Query understanding really is us, or people on the back end, trying to understand the intent of the search user by extracting meaning from the searcher's keywords. So the search term that you use, what do you mean by that? And it often takes place before the search engine retrieves and ranks results. So as you can see in the little image here, when you type in sushi in San Francisco, did I get that right? I think I did. You can see that the intent here is really exploratory. You're exploring options to have the best sushi experience in your life in San Francisco, probably for lunch. And from that, you want to be able to identify, sushi or Japanese food as a cuisine, San Francisco as a location, and lunch as a time of day. There are a number of really important things to build that are important to building a query understanding API. And I'll talk about a couple of them today. The first one being what we call tokenization. So tokenization is, let's say you have a search phrase, right? You want to break it up into distinct elements that ElasticSearch or Node can make sense of. So it's the way to break up text. Text transformation is to normalize and filter characters that are coming from your search term to really make sense out of what you're searching for. And you want to normalize it in a way that suits your business need. And oftentimes, you want to modify the query after you interpret it to reflect the user's intent. Last but not least, with the example I was giving earlier, you want to be able to identify and locate these entities among or on your search term. So the example before being San Francisco as a location entity and sushi as a cuisine entity. So at OpenTable on the search team, our query understanding API is built using Node and ElasticSearch. And as you all know, Node allows you to build an API. And in our version, it takes the search term and interpret the user's intent. It query the data store, in this case would be Elasticsearch, and then it would identify the entities that are relevant to your intent. And Elasticsearch is used to store these tens of thousands of entities. And for today's example, it would be a locations index, cuisines index, and a restaurant index. And you're like, what the heck is an index? I'll talk about it in a minute. So today's agenda, I'll give a very brief introduction to what Elasticsearch is and the few key concepts of how to just get started, which includes what an index is, what is indexing, and then tokenization, as I mentioned earlier, and also how do you go about querying an index. In the second part of the talk, I'll talk about how I go about building the query understanding API, which again really boils down to how you transform the text, tokenize it, potentially modify it, and then retrieving and recognizing entity. Quick intro to Elasticsearch. So I'm not an expert, so these are some high-level things that you should be aware of that can get you started in Elasticsearch locally. It is distributed, it's RESTful, it's a search engine. It stores data, but it's really mostly used as a search engine. And it can do high-performance full-text search. And what I mean by full-text search, I mean you can search with like many number of words in a phrase. So you don't have to give it one term or one word. You can give it a huge sentence or phrase or blog post. You can do the search. And the main purpose of Elasticsearch really comes down to indexing, searching, and also it can provide real-time statistics data relevant to your search. It's also schema-free. It stores the data in a JSON format or document, and it can also detect the data structure and type. And I would say it's relatively easy to set up. So there are a number of important concepts from Elasticsearch that you should know before starting building a query understanding API. And these are some of the concepts that I'll talk about today. And again, I'll talk about why indexing and tokenizer are important, how to query the index, and a scoring function that you can potentially implement. And there are also other plugins that Elasticsearch supports that can allow you to do really cool searching. It could support a synonym search. So let's say you search for Mermaid Restaurant, but then the name of the restaurant itself is actually Mermaid Cafe. You can actually set up Elasticsearch to do it in a way that retrieves all the documents that are synonyms of the search term. And it also supports something we call stemma tokenization. Does anybody know what a stemma is? All right. So what a stemma is that, let's say you have thousands of reviews and you want to search for a flavorful bouillabaisse. And for stemma tokenization, if you enable it in Elasticsearch and set it in a way that makes sense, it would retrieve all the results that are stemmas of the word that you choose for. So let's say it was flavorful, it could retrieve all results with the word flavor in it because flavor is stemma of flavorful. So there are a number of cool things that Elasticsearch allows you to do, and feel free to take your time and explore those options. Does anybody know what an inverted index is? All right. So inverted index is kind of in the opposite of what you think of a traditional index, which we call like forward index. So a forward index is simple. So let's say you have a document with a number of words. So a forward index would list out the frequency of each of the word of the document. But for an inverted index, it's kind of the opposite of that, like I was saying. Let's say you have 3 documents here. Instead of getting the list of words that appears in each document, you actually get a list of all the words that appeared and the frequency of each of the word, along with a list of documents that each the word belongs to. That's a mouthful. But as you can see from this example here, it really is designed to allow very fast full text searches, while forward indexes doesn't really allow that. since you really only have to look for the term once and retrieve all the documents that has the term. But oftentimes, search engines use both forward and inverted index, where the inverted index actually builds by sorting the forward index by its terms. And that's how ElasticSearch can give high-performance full-text search. So, tokens, tokenizer, tokenization. As I was saying before, you have a search string that has multiple words. It could be word, it could be a character, it could be a punctuation. How does ElasticSearch or your API make sense of how the data it receives, or make sense of the data that it receives? So tokenization is the process of breaking up the text into distinct elements. And these elements could be words, it could be sentences, it could be characters, depending on, again, the need of your search. And this process, being called tokenization, breaks down the sentences into words, which we call tokens. So from this example, I feel like it's maybe a little not magnified enough. But there's this sentence that says, heat slowly, stir gently, while adding 25 grams of flour. And with the out-of-the-box Elasticsearch tokenizer, it will be broken down into words that are basically separated by white space. However, if you notice that 25 was actually one word separated by a dash, it retains the meaning of 25 without splitting it into two tokens. And there are a number of very different tokenizers that can do really wonderful things. It could handle different punctuations, Unicode characters. It could also handle compound words like motorboat, or German words that I can't pronounce, but it combines many words into one word. And as you can imagine, it has to be language aware. So you can imagine that if you break up English sentences into words, that makes a lot of sense. But you can't really apply that to Japanese or kanji or any other languages that doesn't work like English. So now, after you know how to create an index, or what an index is really, and how to break up the text into tokens, how do we go about querying an index? So I'll give a very simple example. You can, when you create an index, query an index, there are a number of different ways to do it. And one of the ways, the way that I'll show today is fairly simple. You have to specify the field on the document that you're trying to query against. So say I have a document that has a field called name, and I want to search for Red Lobster. And by simply doing that, that would get you any documents with Red Lobster in their name. There are many other things that you can do to perform a better search. You can filter out things that you don't like or don't want depending on your needs. So in this example, you can filter out documents with the field is listing, and I don't want basically any restaurants that's a listing, is what this is saying. And after you made the query, this is an example of a response that you could get back. There are a number of really cool things that would help you build your API. That includes how long did that query take? And also, how many hits did you get from the search? So maybe you have 20,000 documents and you got 11 back. Okay. And obviously, you would get back the list of documents that you're trying to match up on. And in this case, you can see that my documents, it's set up with many different fields. It could be text, so the name is Red Lobster, blah, blah, blah. It could also have other information that are not string or arrays of strings. It could be a number, it could be a geolocation, and so on. And there's also an option to rank these documents with custom scoring function. So you can rank these documents based on your need. Maybe you want the Red Lobster that's closest to a certain net long, or maybe you want a Red Lobster that's in a different state. So now that you understand the basic concepts of ElasticSearch, I'll talk about how I go about building the Query Understanding API. So when you search for, say, sushi in San Francisco again, in the first phase, we want to be able to parse the term. Like I was saying, you want to be able to transform your text, tokenize it, and potentially modify your query. And after you do that, you want to use your ElasticSearch to retrieve the documents which we called entities. And after that, you want to be able to sort these documents or matches in the subcategories so we can better identify the correct match for your intent. And hopefully you get all the sushi restaurants in San Francisco. Okay, so I'm going to dig deeper into each of the phases that I just talked about. And the first phase being, how do you handle the search term? And you might think this is trivial, but there's actually pretty interesting stories behind all of these things. So first of all, as you can imagine, you can have restaurant names that comes in that has really interesting names and punctuations. And you want to be able to account for all of those cases. At the same time, you don't know how smart your search user is. They might have extra white spaces at places that you don't like. It might be a weird letter case that you also don't expect. And after you parse the term, you want to think about how you want to normalize and transform your term in a consistent way that would give you consistent results based on your business need. So for example, let's say there is a restaurant called Eliotos, and it has an apostrophe. Should I remove that apostrophe, or should I replace it with a white space so that would become a second token on the search term? Or should I just leave it alone and keep or retain the meaning of what Eliotos is? The other case of normalizing terms is, how would you handle stop words? And by stop words, I mean words that don't really add much meaning to what you're searching for. So examples would be the word the, a, or and. So restaurants could have a name which has a number of stop words. And should we go about removing these stop words when we do the search, or should we process the documents in a way that makes sense? And did you know that there are 3 types of dashes? And again, the lesson learned behind that is you really should have input validation. So talk to people who do your data input and make sure that they normalize the way they input data. The lesson behind that is we encounter restaurant names that has very weird punctuations that is used in Microsoft 97. And we're like, what the heck is that? And it took us a while, as you can think, because I can't just look at a dash and tell you which dash it is. So after you have transformed the term, break up the term, how do we set up the query to retrieve these entities from Elasticsearch? As I was mentioning earlier, there's something called the full text query. And again, by that I mean you search for a phrase with multiple tokens, multiple words. And to carry a full text query, you need to specify the field of the document that you're trying to query it against. And for each of these field or documents, you can specify something called an analyzer, which is a way of how Elasticsearch breaks text up into tokens, handle casing, and etc. And that's also part of the custom scoring function, which is slightly long and complicated, which I won't get into today, but again, feel free to look it up yourself. But there are 2 types of, actually there are a number of query types, but I'll talk about 2 of them today. So one of the query type that we use on a daily basis is called a match phrase query. And what that is it's usually used for matching exact phrases. And I will talk about this example. Let's say you have 3 documents with the field message, and the first one said, I just said hello world. The second one said, hello world. The third one said, word hello. If you do a match phrase query with specifying the field message with the term hello world, you would only get document 1 and 2 back, because hello world is not an exact subphrase of world hello. On the other hand, there's also something called a match or a multi-match query that is slightly different than what we just talked about. So essentially, if you run a match or a multi-match query with the same field message with the term hello world, you would actually get all the documents back, because when you do a multi-match query, it breaks up hello world into 2 tokens, 1 for hello, 1 in world. And it go and look into all of the documents and see if any of the documents has both of those tokens. So in this case, you get all the documents back. So after you've set up the query and decide the query type that you need to use, let's go ahead and query the data. So we'll use sushi in San Francisco. And in our example, we'll query the cuisines index, the locations index, and the restaurant index. So those are different documents that represent cuisines entities, location entities, and restaurants entities. And after that, we'll get all the documents back ranked. So now that you've generated all these documents / entities, how do we narrow down to the right match? So in the first phase, you probably want to consider filtering out incorrect matches. So an example that I use here is, let's say you search for sushi in San Francisco again, and there's a restaurant match that came back called Sushi Zen. Would you consider that a correct match? And how would you go about filtering out any incorrect matches? And this is where your JavaScript talent comes in. You can do a term inset. You can create a set of the terms and try to cross it out, or you can do like substring matching between any of the terms and any of the matches and filter out incorrect matches that way. But there's a number of ways that you can do that. But what about matches with stop words and synonyms? Like I was saying before, there are a number of stop words that adds no meaning to the document or the search term. And there are a number of different synonyms for, say, the word restaurant. And how would you handle matches that are synonyms of each other? So due to the very vibrant Node community here, there are awesome open source libraries that you can use to help you facilitate that. And obviously, feel free to look it up if you're interested. So after you filter the incorrect matches, what about entities that are conflicting? And what I mean by that is, say you have a restaurant called sushi. You also have a cuisine entity called sushi. Which one should you give back to the user? Do you think they're looking for a restaurant called sushi or the cuisine type sushi? That might be obvious to some of us, but what about this? What about locations and restaurants who has the same name? Did you know that there is a Portland restaurant in London, United Kingdom on Portland Street? I do not. I mean, I've never even been there. But for most of us who live in the United States, you would think if people are searching for Portland, I probably should get back the Portland that is in Oregon.
What about Maine?
Maine. That's true. You're right. Good point. Yeah, see, a lot of difficulties here. OK, so after we have correctly filtered out the incorrect matches and handling conflicting cases, we want to go about sorting these matches to give a better match for the user's intent. So for location matches, let's say somebody searched for Chinatown, Chicago. It's pretty easy to tell that they're looking for the Chinatown in Chicago, even though there's numbers of Chinatown all around the world. And oftentimes we do that. We sort location matches based on a search location that we infer from the user's intent. And in this case, we get back Chinatown in Chicago. But what about when people search for London? Are they talking about the London in the United Kingdom? Or are they talking about the London in Ontario, Canada? And there are a couple ways to think about that, right? Like the same kind of principle applies. You probably want to return the closest London relative to where the user is, right? But then at the same time, you might think about, there's probably a higher density of restaurants in the London in the United Kingdom compared to the London in Ontario, Canada. So which one should you go about returning to the user? And similar principles apply to restaurant matches. So say you search for Red Lobster in Boston, and there's a number of Red Lobster in the whole United States. And again, from that, we can infer what the user is looking for by understanding the location intent from the search phrase. But again, when people search for only Red Lobster, same use case apply, where you probably want to return the closest Red Lobster to where the user is making their query. But then again, we recommend the best restaurant to you, so not only location matters here, right? What about popularity of the restaurants? What about booking availability? What about reviews quality? So there are a number of things that you can think about, or we think about on a day-to-day basis when we recommend the best restaurants to you. So now that we have modified, transformed, breaking down the term into tokens, and query ElasticSearch database and handle ranking and removing incorrect matches. We have correctly identified sushi as a cuisine entity and San Francisco as a location entity. And now we go ahead and generate all the awesome sushi restaurants in San Francisco for you. And that's how we make money. Okay, so what's next after query understanding? So there are a number of things that the search team is exploring after or along with the query understanding API. One of the things is what we call query prediction. So let's say you go search for eggs. You might be looking for Eggs Benedict, a restaurant called Egg and Things or Egg and I. But it's likely that you actually end up at a breakfast restaurant or American-style diners. And we want to be able to predict that. And another thing that we really want to explore is what we call query expansion. So let's say you search for Tantan noodle. And with the example that I gave earlier, I might not be able to identify any identities or entities from Tantan noodle. But if I can expand it into different intents, Tantan noodle is spicy, it's a Sichuanese food, and it's Chinese food, then we can hopefully use these expanded queries to retrieve better results, even though we didn't identify any entities from Tantan noodle. So coming to a full cycle here, when you search for sushi in San Francisco lunch, and you get a bunch of restaurants that has sushi and Japanese in their menu and around lunchtime. But the mission to recommending the best restaurants continued, and that is the end of my talk. Thank you. I don't know if there's Q&A. Oh, Q&A, anybody?
Who got questions?
Okay. Do they have mics?
Here. I'll
This
So is it ever a case where you would be presented with a disambiguation page like you have on Wikipedia? Like if it doesn't know what your intent is, like whether you mean London, Ontario, or London, United Kingdom, do you ever present a disambiguation page to have the user clarify what their intent was?
Yeah, I see what you mean. I think we are in the process of doing that. We call it like query recommendation or suggestion. Basically, we would say, an example would be, let's say you search for New York pizza. Do you really mean New York pizza as in you want to find pizza restaurants in New York, or are you searching for New York style pizza in San Francisco? So that's something we're definitely exploring to basically let the user pick whichever intent that they actually mean by us giving them two choices, or maybe more than two choices.
How do you handle real-world feedback? So if you have a search and it clearly gives something that wasn't the point,
Yes.
do you try and go and fix or change the entire algorithm, or can you do like specific tweaks to the search results and say, like in this case, we want to do something and we haven't figured out?
Got it. So I think my answer to the question is, for most of these features, we have broken it down into basically many, many A/B tests. So every time we want to roll out a feature that allows us to do a certain functionality, we A/B test on it. So like the way that we predict whether the search is relevant or not, or whether we actually predicted the user's intent is through conversion. So did people make a reservation on OpenTable? If that answered the question.
How do you get all of the data into the database? So like tons of different cuisines and then different sub-types of food in each cuisine. Seems like a lot of sort of manual work that would have to go into that. Or do you have some kind of machine learning?
Yeah, that's a good question. So I guess OpenTable, at least my team operates in like a microservice environment. So we have a microservice that handles the cuisines data, and another microservice that handles like locations data and so on. So oftentimes, let's say like, I would say that the example I would give is, let's say restaurants data, it would actually come from a salesperson or the restaurant owner itself. So we're a two-sided B2B business. We allow the restaurant owners to input their own data, and we do some basic validation, and that's how we get the data from the restaurant side. But I think locations and cuisines, there's probably some pretty complicated process which I do not know the answer to today.
Anybody else? No?
so when you have the example of the tauntaun noodles, it's like I've heard of them called don don noodles.
Ah,
and
yeah,
the thing
yeah.
is that like there's Chinese food words that come from Cantonese and that come from Mandarin.
Yes.
And so how do you take care of that? And also for a cuisine like Korean, Korean used to be Romanized a different way than it is now. There was the McCune Reicher Romanization. Now they've changed to a different Romanization. And so you can have two words that are the same for the same food in Korean.
Right.
How do you handle that?
Yeah, that's a really good question. I think for now, so like the tauntaun and the dandan noodle example, we might not do a very good job in handling that, but like kind of a relevant example would be diacritics. So let's say you're French or Italian or Spanish, yeah. And let's say you search for San Jose with the little squiggly line on top, so we do handle that. We have a way in processing and removing or replacing diacritics from the documents and the search terms so we can normalize the way that people search.
All right.
All right.
Thank you very much.
I'll put it down. I'll give it to you. Never mind. Thank you.